Build, train, and deploy a machine learning model with Amazon Sagemaker. So for this, first step is to enter the Sagemaker console. For doing so, open this Amazon Web Services Management console and then start typing SageMaker so that it can select the Amazon SageMaker to open the service console. So once this is done, you can create a SageMaker notebook instance. So for creating this, go to this Amazon SageMaker dashboard and select create notebook instance. So on this create notebook instance, then in this notebook instance name, type my SageMaker instance so that your instance can securely access S3 and another Amazon Web Services. SageMaker can create a new IAM role with the permissions and can assign it to your instance for you. So instruct SageMaker to create this IAM role by selecting create a new IAM role from this IAM role drop down menu. Okay. So once this is done, on this create an IAM role, select any S3 bucket which will allow your SageMaker instance to access all the S3 buckets in your account. Now select create role. Next, you will notice that SageMaker made a role called Amazon SageMaker execution role for you. So on this create notebook instance panel, you can optionally place your instance in VPC, set a lifecycle configuration and an encryption key. So all these things are optional. You can leave them for now. The next step is to prepare the data. So in this, we will use your Amazon SageMaker notebook to pre-process the data, which we need to train the model. So on this Sage notebook instances pane, after my SageMaker instance has transitioned from pending to in service, select open from this actions column and open the Jupyter notebook. So once this Jupyter comes up, my SageMaker instance in the file step, click on new and then choose Conda Python 3. To prepare this data, train the model and deploy it, we need to import some libraries and define a new environment variables. So for this, we will copy this code and run it. So after running this, we will find that it has been successfully run. The next step is to create an S3 bucket so that we can copy this code and simply run it. So once we have created this S3 bucket, we need to download the data to our SageMaker instances. For this, simply copy and run this code. The next step is to shuffle the data and split it into the training and testing data set. So the training data is a 70% of the customers which we are using and 30% is a test data set. So for this, simply run this code. The next step is to train the model from the data. So here, to use the SageMaker pre-built XGBoost model, we need to reformat the header and first column of this training data. So simply copy and run this code. The next, we need to set up a SageMaker session, create an instance of XGBoost model and define this model hyperparameter. So for this, we will run this code. And finally, with the data loaded and XGBoost estimator setup, train the model using gradient optimization on an ml.m4.xlarge instance by running this code. And next step is to deploy the model so that we can create an endpoint which we can access this. So for this, we will simply run this code. Next is to predict whether the customers in the test data enroll for the bank product and not. We will simply run this code. And we will evaluate this model performance by running this code. So here we will see that we have gotten confusion matrix. So from this confusion matrix, we can predict that the outcome is accurate for 90% of the customers with a precision of 65% for enrolled and 90% for who did not enroll. Then this model can now be fine-tuned as per the requirement. And the next step is to terminate your resources. So in this, we need the termination of resources so that it does not increase the cost. So for terminating the resources, we need to delete the SageMaker's endpoint. So for this, we will simply use this code. So finally, the code is deployed to the Amazon SageMaker. Okay.